Hello, my name is David Giglio from Ozen Engineering, and in this video I will show you how to use the Ansys Electronic Transformer ACT to automatically create a 3D FEM model in Ansys Maxwell of a transformer or inductor. The first thing is go to catalog.ansys.com, download the ACT for free, then go to your project, Maxwell Design, click on View, click on ACT Extensions, select the Electronic Transformer ACT, and the window appears to apply the settings for the model creation. If you click on Help, you will be able to download documentation that will explain all of the parameters. The first parameter here is the segmentation angle, and it represents the resolution of how the curvature of the geometry is created. There are multiple suppliers to choose from. I will leave the default ferrous cube and multiple core types to choose from, a maximum of 15 core types. I will choose ETD 442215. We can define an air gap or leave it unchecked. Click Next. We can choose transformer to be wound or planar. I will leave it wound. We need to select number of layers, which equals the number of windings. A layer represents a winding. So how many windings? I will choose 2. Everything else default, except we can choose conductor type, rectangular, circular. I will choose circular. We need to define layer properties, conductor diameter. Depending on what gauge you want to use, I want to use 10 gauge, so it's 2.5 like 88 millimeters. The length in the ACT is measured in millimeters. Select the turns, 6 for each, 1:1 transformer turns ratio. Insulation thickness, I leave default. So next is select the set up the analysis. We can choose to make model full or let the ACT to use symmetry to create a half model so that the simulation can converge quicker. And for core material, I will choose 3C94, copper coils. Frequency, we could define it here or afterwards, doesn't matter. Same thing for defining Fixie Sweep. We can define it here or after the model is created. Here we need to choose the transformer size. So for a transformer, we need at least 2 sides. And we need to define the windings. So 2 windings and 2 sides, 1 winding in each side. Define connections. The 2 windings are not connected electrically, they are only magnetically coupled. So there are no connections to be made. If there were windings, more than 1 winding in a side, we will need to define whether the windings are connected in series or parallel, or we can ungroup them and group them in another way. So I'll just leave it as this, okay. I will uncheck create skin layers for mesh. You could read this more, get more details in the manual by clicking help. So here now I'll set up analysis to create the model, and as you see, the model is being created, and within seconds the model creation is completed. Almost done. There it is, it's done. So I could exit the wizard, close it down, zoom out a little bit, click on the region, hide it, so I can show you what has been created. Now, I had already pre-created this model, so I will go to the model I already have. And also, besides the geometry, we have a Maxwell Circuit created, which defines the excitation to the transformer. And here I have added voltmeter to the winding, ammeter in the branch of the primary, and voltmeter to the excitation. This is shown in page 1, and page 2 I have a voltmeter measuring winding 2 and an ammeter in the secondary. So going back to the Maxwell design, as I mentioned, we can set up the Fixie Sweep by clicking on Setup 1, Fixie Sweep. Here I've chosen a linear step starting at 100 kilohertz, ending at 200 kilohertz, and using a step size of 50 hertz. core material, we can select the core in the geometry, click on material, click on edit, view material. We can see the material properties, and for relative permeability, by default it's simple. We can choose to use nonlinear BH curve. We can enter a BH curve file, set the file type to TAB, and here you see the BH curve. You can also manually enter the data for the BH curve. I will click cancel, and for post-processing you can click on results, right click, you can create a data table, and you can see coupling coefficient data, inductance data, showing leakage inductance and mutual inductance for each winding, resistance of the windings, impedance of the windings, branch currents measured from the ammeter set up in the Maxwell circuit, similarly for node voltage, losses in the windings in the core. Also, after using the Electronic Transformer ACT to create the model, the ACT automatically creates and saves a JSON file containing all of the model information. This is a JSON file spelled JSON, not Jason Voorhees as in Friday the 13th. This file contains all the model information, including information for the core dimensions, winding definition, and setup definition. You can use this file to create the model using the ACT from the beginning, or you can edit this file and create the model as well. For example, you can click View, ACT Extensions, Electronic Transformer, Open Example, go to the file you want to open up, open, all the information is set up, and you can go to the end, set up analysis, and you see once again the model being created in seconds. And that is all for this video. If you like this video, please click like. Also subscribe to our channel to get notifications of new videos that are updated. Thank you very much and have a nice day.